Okay, so good morning. We will be discussing today about offshore oil rig piping systems. So before going to the webinar, I'll give a brief introduction about myself. So I'm Sanal Matthews. I'm the principal consultant and director of Canotech Engineering Consultants. So we are basically into design and consulting services for marine, oil and gas, and offshore sector. So this is our fourth webinar. Earlier we had webinars in piping, valves, and pumps. So it was brief introduction topics. So now we'll be going into the piping systems. Okay, so we will just a minute. Okay, so the webinar agenda for today will be just we will discuss in a brief about offshore oil rig, and we will see few piping systems. So the systems which we will be seeing today mainly includes fire system, bilge system, raw water system, and preload ballast system. We will see its application, purpose, operation aspect, etc. And finally, we will proceed to question and answer session. Okay, basically, offshore oil rig. We know it's for drilling oil wells. And drilling oil wells, we have like onshore and offshore. Also, whatever drilling we do on the land is onshore oil rigs. And when we move away from the shore to sea, drilling in sea is like offshore oil rigs are used. So it's used to explore, extract, store, and process petroleum and natural gas. So basically, common types which we see are jacked up drilling rigs, which we will be focusing mainly in our discussion today. And for deep water drilling, we use drill ships and similarly FPSOs, which are floating production, storage, and offloading vessels. So as the name suggests, it has both production, similarly storage facilities. The tanks are converted for storage and offloading it to subsea, offloading through subsea pipelines to the shore. Okay, about offshore oil rig, just for brief intro, we can see the steel structures, the vertical structures, which are the legs. This is for fresh graduates who are present in the webinar. Similarly, there is a hull body, which is jacked up and down. Also, in the second picture, we can see that there is a cantilever which moves in the forward of direction. Similarly, derrick, which accommodates the drill floor, where the drilling part, entire drilling process is being taking place. Similarly, there is a jack house where the jacking gears are there. Okay, so also the accommodation for accommodating the crew. And the leg has a footing called sputcan. We will not be going into much detail of the entire oil rig features, but this is a brief intro before proceeding to the piping systems. So for offshore oil rig, we can see two views here. One is the machinery deck top view, first one. So that is a machinery deck view where all the equipments are arranged. Similarly, the second picture is the top view of an offshore oil rig, where we can see the heli deck, similarly drill floor, leg positions, cranes arrangement, lifeboat arrangement, etc. Okay, so in this picture, we can see the offshore oil rig in two elevated condition. One is just elevated from above water, and similarly the next one is at a much higher height. So it is just shown for better understanding. Similarly, below water, you can see the how the legs are below water positioned. The footing of the legs is having the spud can. Okay, just for better understanding, we will see how an offshore oil rig works. These oil rigs are not self-propelled, so whatever movement required in sea, we use tugs for the movement. The floating rigs are pulled using tugs. Now the process which is taking place is positioning of the rig to the drilling platform. So once positioned, the rigs are towed to the drilling platform. The legs are lowered. So the leg which is touching now, that is called soft pinning operation. And once it reaches there, it's jacked. The hull body is jacked up and the leg pierces down on the seabed. So the rig is filled with water, which is called the preloading operation, which adds more load so that the leg pierces more. Again, the water is dropped out and jacked up. Now the cantilever is taken outside to the drilling platform. Okay, that is a basic operation, how a rig is brought into a location and drilling is initiated. So we can see this in the screen, various piping systems. So this piping systems, actually we can categorize like for the safe operation of vessel systems like fire system, Bilge system, then fundamental system operations like raw water system, preload ballast system, etc. We will be discussing about these four systems. Other than this, we have general service systems like compressed air, sewage system. Also, the next bundle like for engine rated systems like fuel oil system, low oil system, main generator cooling system, similarly exhaust system for generator, etc. Next, we can categorize the third part to drilling part, which includes the mud systems like low pressure mud, bulk mud, cement, and high pressure mud, cement piping. Similarly, choke and gill manifold piping, BOP piping, which is blowout preventer piping system, drill water system, also well test oil and gas system. Also, next fourth part is there like accommodation piping systems, which includes the freshwater system and the earlier discussed sewage, which comes part of the accommodation. In addition to this, we have more systems like hydraulic system, similarly tank vent and sounding, that is a system. Okay, and the preloading system, which we will cover along with the raw water system today. Okay, so four systems which we'll discuss today are fire system, Bilge system, raw water system, and preload ballast system. Okay, first we will discuss about the fire system. When we discuss about the fire system, this is used for firefighting. Like any vessel for ships or any industrial purpose, the fire system is for firefighting. So in this system, we will see how the system concept is. What is the concept? What all equipments are there, like fire pumps, fire monitors, fixed firefighting systems, similarly fire hoses, valves, booster pumps, etc. We will go through the equipments and gain a concept of the system. So when we see a offshore oil rig fire system, it's basically categorized into two conditions. First is a floating condition, which we can see whether when the rig is floating, it's being towed from to the different locations using a tugboat. So this is a floating condition. And next condition, what we are seeing, next photo is the elevated condition. So in elevated condition, we can see the hull body of the rig is jacked up. So bottom of the hull body to seawater level. That gap is called the air gap. So fire system will be discussed in two cases, one in floating condition and one in elevated condition. Okay, so we'll see about fire system design. Now what we are seeing, the green line, which is the seawater or raw water system. So this is the main seawater system, which is supplying the rig with all the seawater requirement. So in elevated condition, this is the first condition, fire system in elevated condition. We will have two fire pumps. One is a main fire pump and one is an emergency fire pump. So this is an ABS requirement. Like minimum two independently powered fire pumps are required in marine vessels, ships, offshore rigs, etc. So not only ABS, other classification societies like DNV, Bureau Veritas, DINA, all recommend these two fire pump requirements as per SOLAS requirement. So the main fire pump can be electric driven or engine driven. Any form can be provided. Similarly, the emergency fire pump should have an alternate source of power. Like in case of main power failure, there should be an alternate source of power. It should be either it can be either engine driven source or it can be either another emergency electric power source from an emergency generator, which is widely used. So we will see the system. It takes suction from the seawater system of the rig and it supplies to a ring main fire system. This is a general concept of a system. Each rig will have a slight change in the design. In some rigs, it may not be entirely a ring which is visible, but in as per design, it will be a ring main fire system which supplies to accommodation, helideck, floor, and to machinery space and all decks. So for firefighting, we'll have fire hydrant hose locations throughout the rig in all locations, all machinery spaces, accommodation, decks, main deck, drill floor, cantilever area, helideck area, etc. So helideck has a separate requirement, like helideck needs foam firefighting. So it is a marine class requirement, safety requirement that helideck needs foam firefighting. So for helideck, we provide additional foam tanks, which will supply foam for operation. Similarly, helideck has two firefighting methods. We will see in the future slides. So this is a basic concept of a fire system, and we need isolation valves. We provide valves accordingly so that any breakage in the system at any part will not hamper the system, will not completely collapse the system. It means if I supply to a machinery space, if there is an explosion and if the fire line breaks, we should be able to isolate the fire line from the next compartment so that we do not lose the entire firewater on that compartment. If we lose firewater on that compartment, apart from the explosion, it will lead to flooding, so which will lead to more damage. So to prevent that, we have to isolate the fire system from the next compartments which are accessible. So every compartment will have an isolation valve on the fire header system. So this is a basic concept. So we will have an option to supply to raw water system, which we will discuss in the raw water system part. Okay, so fire system in floating condition. As, earlier we discussed fire system in the elevated condition. Similarly, we have same fire pumps, emergency fire pump. But the main difference to be noted here is the supply is from sea chest because the rig is floating. So in floating condition, the seawater header, which we discussed, is not being fed. So for taking suction for fire system. So in this floating condition, we take suction from sea chest. The system entirely is same. Only difference is the suction point changes. All the supply, all the isolation, everything remains intact. So since the raw water system does not have a feed during floating condition, these fire pumps supply a feed to the raw water system. So that is how the raw water system, I mean the seawater system in the rig gets water during floating condition. But there will not be much consumption for seawater because in floating condition there is no drilling operation. Drilling operation is always taking place in elevated condition. So floating condition just has a minimum requirement for seawater, which will be met using fire pumps. Okay, so this is the basic concept of the fire system. It has two conditions, elevated and floating. So in elevated condition, suction is taken from the seawater header lines, and in floating condition, it's taken from the sea chest. So once this concept is clear, designers can design accordingly. Based on the rig design, routing can be done accordingly, valve placing can be done in a wise manner. Okay, so fire pumps, when we discuss about fire pumps, these are centrifugal pumps due to the capacity requirement. So general offshore oil rigs like jackup rigs, which we see in the market, has fire pumps of like 700 meter cube per hour minimum capacity at 16 bar, like 120 meter head. It will be the total delivery head of the fire pumps. So it can be used like we can use for specification. We can take like bronze casing, similarly bronze impeller, stainless steel shaft, and the fire pumps has to be self-priming because of the centrifugal pump property. This has to be self-priming. It is a class requirement. Okay, so apart from this, what we have to see is the fire system. This is a basic fire system designed for a rig. So there are more rule requirements like this heli deck, which we mentioned, maybe at a higher height. The deck is usually at a higher height. So for this height requirement, there is an optional booster pump addition, which we can provide to meet the height requirement. So that is usually seen in the rigs. Also, ABS has fixed firefighting requirements like for machinery space, category A machinery space, which is a machinery space which has internal combustion engines like main generator room or emergency generator room. So there is a rule requirement. So there is a value like engine kilowatt, like 375 kilowatt. So those are rules actually. So any equipment internal combustion engines above 375 kilowatt placed in an offshore oil rig has to have fixed firefighting systems. So we use generally CO2 or FM200, which is used, but CO2 is widely used. We'll see in future slides. So we'll move to the next slide. Okay, this is just a layout of fire system. We can see three leg well areas. We can see how the lines are routed throughout the rig. Is the slide visible? I hope the slide is visible. Just a minute. Yeah, I hope the slide is visible. Okay, so fire system design, we can see the layout, how the pipes are routed through the port side, starboard side. The general layout. So each rig will have a different design. Similarly, supply to head supply to drill floor, cantilever area, shell shaker area. So there is a detailed design part. Okay, for in the fire system, we told like the fire hose boxes are positioned in different locations throughout the rig. So once we open the box, this will be the arrangement of fire hoses, like how the hoses are kept inside with a nozzle connection. Okay, so hydrants. These are hydrants, fire hydrants positioned at various parts of the rig. There will be hydrant valve for operation. There will be, in this case, we can see two hydrant valves. So there is a common isolation valve. Okay, another view of hydrant valves. It's another view of hydrant valves. Okay, this is for helideck. For helideck firefighting, what we are seeing is a person operating a fire monitor. We'll see more photos on that one. So when a fire monitor is in operation, this is how the throw of water can be seen. The view of fire monitors, which has movement, we can manually operate it to the required direction. Okay, this equipment, what we are seeing is a fire pump. So fire pumps. Second picture is a fire pump layout in a fire pump room. So the second one is an engine-driven fire pump. We can see the exhaust lines and all the routing provided. Okay, fire system in helideck. We have actually two options for firefighting in helideck. One is using fire monitors. That is the picture which we see here. Fixed monitors are located throughout the helideck at different points. So it can be operated by personnel. Similarly, the second picture, what we are seeing is the deck integrated firefighting system. It's called Diff system. So deck integrated firefighting system enables firefighting without direct personnel operating an equipment. It just has to be activated from the activating point, which is below the helideck. So once activated, nozzles are positioned throughout the rigs. Throughout the helideck deck point. So around usually the arrangement is like around 16 to 20 nozzles will be positioned, but depending on the helideck size, this nozzle numbers vary. So these nozzles, the system once activated, these nozzles spray water, which we can see now. So it will spray water for 5 minutes, which is as per the rule requirement. Okay, we earlier discussed about fixed firefighting system. So fixed firefighting system, like now we can see in the slide first picture, which is the emergency generator room CO2 cylinders. Similarly, the next picture, which is it is showing the main generator room CO2 cylinder arrangement. So emergency generator room is actually a small room with less volume. So based on the volume calculation, few cylinders are required for fixed firefighting. Similarly, a main generator room, which is a huge volume, so the cylinder numbers increase accordingly. Okay, so that was about fire system. So we will go to the next system, which is the bilge system. Bilge system is widely seen in ships and other vessels. Similarly, in offshore oil rigs, we have a bilge system. It is a simple system used for removing the bilges from the offshore oil rig. Like a bilge is oil plus water mixture or oil plus water plus fuel mixtures which accumulate in various parts on the rig. So this bilges, once accumulated in a location, we have to remove it on a continuous basis to keep the machinery space safe, clean, and to prevent flooding, etc. So various equipments used in the bilge system includes bilge pumps, bilge holding tank, which is also called a skimmer tank. Similarly, oily water separator or sludge tank, which is also called as the dirty oil tank. We will see what is the concept of the system. Okay, the bilge system has two pumps, like two independently powered bilge pumps are required. So every offshore rig, oil rig, will have minimum 2 bilge pumps. So it will be taking suction from bilge wells. So bilge wells are located in the machinery spaces like main generator room, fire pump room, sewage treatment plant room, freshwater maker room, similarly air compressor room. So all these machinery spaces, whichever rooms, will have bilge wells from where we can take suction to bilge pumps. So independent suctions are taken from each compartment. The common header which we can suction header which we see here is actually placed in the bilge pump compartment. It is a small compartment usually. So near to the bilge pump are the headers. So separate bilge suctions are taken from each bilge well up to bilge pump suction, and the discharge is taken to a bilge holding tank. So bilge pumps take suction from bilge wells and discharge to bilge holding tank, which is also known as skimmer tank. So it holds the bilge water. So from the bilge holding tank, we the suction is taken by the oily water separator from the bilge holding tank. So when we talk about oily water separator is an equipment which separates oil and water. The function of oily water separator is to separate oil and water. We can see in the picture how the system works, like bilge pumps taking suction from bilge wells and pumping it to bilge holding tank, and oily water separator is taking suction from bilge holding tank. So once the oily water separates oil and water, the clean water we can discharge overboard. So by clean water, we mean there is a value like 15 ppm parts per million. So 15 parts per million of oil should be present in the water when we discharge it overboard. So there is an oil content monitor machine which is part of the oil water separator. So this will measure the oil content in the discharge. So if it is above 15 ppm, the oil water separator do not discharge it to overboard. Similarly, there is a log recording in the oil water separator. Any discharge which is made from the oil water separator gets recorded in it. Even the coordinates, time frame, all these details will be recorded. So that is about the oil water separator operation. And once we separate oil and water, the clean water once we discharge, so the remaining oil which is separated, we need to store it in a location. So that is where the dirty oil tank or sludge tank comes into place. So this oily water separator will separate oil and water. So the separated oil will be stored in the sludge tank or dirty oil tank. And once it fills up, we can discharge it to a supply vessel. So we cannot discharge the dirty oil to directly overboard. So this has to be stored and kept. So frequent visit of the on a visit of the supply vessel, we will empty the sludge tank to supply vessel. Similarly, in the system, when we use when we see the bilge well suction area, so the bilge well suction area, there is a class rule requirement of stop check valves. Like there should be a stop valve and check valve. That means an isolation valve and check valve. Okay, so in another we can consider another option is SDNR valve, screw down non-neutron valve, which is a single valve which meets the rule criteria. This rule is kept to prevent bilge contamination. Like from one bilge well, when we take a suction, it should not flow to next bilge well, which is a safety aspect for the vessel, safety and hazard aspect. So this rule requirement to meet this rule requirement, we have to give stop check valves, which is a form of SDNR valve. So SDNR valves prevent the return flow of water to the bilge well. Once suction is taken, the fluid always stays inside the piping system. It will not flow back to the bilge wells. Similarly, bilge pumps, which we widely see in the rigs, are centrifugal type. And these centrifugal type pumps Usual capacity ranges from 80 to 140 meter cube per hour, and the discharge head will be like 40 to 60 meters. So depending on the vessel requirement. Okay, so when alternate to this, we also see diaphragm bilge pumps in the offshore oil rigs. This is used where mud accumulates in the bilge well. Certain bilge wells located in certain rooms. There is like four-sack room, similarly mud pump room. So mud accumulation happens in these rooms in the bilge well. So due to the more mud content in the bilges in these rooms, we use a diaphragm bilge pump, which can be a fixed option or a portable option, which we can use accordingly. So this is a basic system of this is a basic concept of build system. Designers can improve on this system as per each requirement for each vessel. Okay, so now what we are seeing is a build system diagram with detailed layout. Like we can see individual lines from each tanks or each location, each machinery space. All these machinery space separate lines are taken up to the bilge header, the bilge suction. Similarly, we can see bilge discharge. Okay, so discharge we discussed in the system. Discharge will be done to the bilge holding tank, from where it goes to the oily water separator, and which separates, and clean water is discharged overboard, and oil which is separated stays in the dirty oil tank. It's a very simple system. Okay, now we can see we earlier discussed about bilge well. So this is how a bilge well will be seen in the vessel. It will be a lowered portion on the machinery deck. The pipe which is seen is a suction pipe. Similarly, another bilge well. Also a different photo of bilge well. Okay, so this is a photo of a bilge well. We can see inside a pipe which suction. There will be a strainer inside at the end of the pipe inside bilge well, which we can call like a rose box. It is also called rose box. It is a strainer. Okay, so next we can see the bilge pumps. These are different bilge pump arrangements. Just a pictorial representation. Okay, we discussed about sludge pumps. So bilge pumps earlier we discussed. Bilge pumps are generally centrifugal type pumps, which will be self-priming pumps. But here what we are seeing right now is a sludge pump, which is a screw pump, which means a rotor pump. So it is a post displacement pump. Why we are using a screw pump or rotor pump for sludge operation? Because of the thick viscous fluid which is in the sludge tank. Also, there will be particles inside the sludge tank. So these particles and the thickness of the fluid justifies the use of a sludge pump. Also, the sludge quantity will be much less compared to the bilge suction which is happening on the machinery space. So the sludge pumping volume, I mean the sludge pumping flow rate will be much lesser. So sludge pump capacity will be like 15 meter cube to 20 meter cube range, 20 to 25 meter cube, 15 to 25. That will be the range of the sludge pump used in a vessel. Okay, so what we are seeing the slide right now is a bilge holding tank. So bilge holding tank is actually has baffles inside. So these baffles separate the bilges, like oil, water, etc. is separated inside the bilge holding tank. That is a natural arrangement. We will not get exactly separated fluid at the end, like what is showing here. We will get a mix of oil and water at the end. So which eventually flows to the oily water separator where it clearly separates. So this is a natural arrangement where baffles are kept to separate the lighter and thicker fluids using the baffle system. Okay, now what we are seeing is a oily water separator. This picture is of a Wärtsilä make oily water separator. Similarly, we have a separate type called RWO make oily water separator. So these are two types. Similarly, a lot of other makers are there. We have shown two. Okay, so now we discussed about Bilge system earlier. We saw about Bilge system. Now we will see about raw water system. So raw water system is basically seawater supply system. It's a system which is used to supply seawater throughout the rig. So in this system, we will see equipment like raw water pumps, which is also called deep well pumps because it is submersible type pumps which we are using in the rig. So two conditions will be used like floating and elevated condition. Okay, raw water system in floating condition, we already discussed the rig while floating will be for transporting the rig, etc. It will be in floating condition. Similarly, in elevated condition, the hull body will be jacked up. So two cases we will discuss for raw water system. Okay, raw water system in elevated condition, we have raw water pumps like main raw water pump. There will be an emergency. There will be more pumps, of which one will be having emergency supply. Similarly, water level. So these are submersible pumps immersed on sea below sea level. So water is pumped to a ring main header system. So seawater system also has a ring main header system, which eventually supplies to fire system like drilling mud preparation, freshwater maker, and preloading system. So this system will have sufficient isolation valves in such a way if the system fails in one location, or the system or the piping system breaks in a location, we should be able to isolate the system. So this is the concept of a raw water system design. So we will discuss about preloading system in the coming slides. These raw water pumps which we see here, usually it has a capacity of like 2000 to 1800, 1600 to 2200 gallons per minute. That will be the usual range of raw water pumps. Flow rate supply 2200 GPM. Okay, so raw water system in floating condition, we can see like in this case, it is in floating condition. So we cannot lower deep well pumps. So what we do is in this case, we supply water throughout the seawater inside the rig for seawater application using a fire pump. Using fire pumps. So it will take suction from sea chest because it is in floating condition. The sea chest suction will be taken for raw water supply. So in floating condition, deep well pumps are disabled. Okay, now what we are seeing in this picture is raw water pumps. So submersible type raw water pumps. Okay, another picture of a water pump. The third one is a much bigger one, which is actually used in FPSO, but the first two pictures are what we see in offshore oil rig types. Okay, with that, we finished the raw water system. In raw water system, when we discussed, we saw a supply of seawater to preload system. So preload system, we will discuss about preload system in detail. Like once the rig is brought to the location, once the we can see that the second picture is install and preload, where the leg is lowered and it is jacked up for operation. So when the hull body is above water, we fill the hull body and there are hull tanks around. We will see the system detail in the next slide. The operation is we will fill the hull body, the hull tanks, preload tanks with water. The load of the volume of water, the load of the water will be approximately equal to the rig weight. So double the rig weight will be giving to the legs so that the leg will appears on the seabed. which will position the rig, which will provide more stability and positioning to the rig. After that, after its position, the preload tanks will be emptied directly to sea. That is preload dumping. We will see it in the next slide. And then the hull body is jacked up according to the operational height requirement. So we'll see the preload system. Okay, in this video, we will just see a small portion. Okay, now the leg is lowered. So after this, we fill the preload tanks, which we can see in this with blue car they have filled, and so the weight addition enables more leg movement downward, and the water is empty. Okay, so this we earlier saw just to describe the preload. We have seen it again. Okay, so preload ballast system, which we are discussing now, is basically the seawater system which is supplying to preload tanks. So there will be around usually 16 to 24 tanks. More tanks, depending on the rig design, there will be more tanks. But generally, we see 16 to 24 range of preload tanks. So these preload tanks enable the preloading operation. So there will be isolation valves, and there will be preload pumps in few rigs. Due to the heavy water requirement, there will be preload pumps. So earlier we discussed the raw water pump capacities. So raw water pump capacities we discussed, it will be usually 1600 to 2200 gallons per minute. Similarly, preload pumps will be higher capacity. It will be like 5000 to 6000 gallons per minute. So preload pumps are used only during preload operation due to the heavy water requirement to reduce the operating time of the rigs. Most of the rigs prefer the use of a preload pump. Once again, yeah, okay. So we will see that is the preloading operational system which we saw earlier. Similarly, we will see preload dumping system. In a preload dumping system, so the hull of the rigs will have various preload tanks. We discussed earlier, like 16 to 24 tanks will be there. So it will be dumped to seawater to the sea directly. Like each tank will have a dumping mechanism. We will see the dumping mechanism in the next slides. We will dump it directly to the sea. There will not be any other any machinery operation. There will not be any pumping operation. Okay, so this is the usual dumping arrangement provided in the preload tanks. There will be a pipe which has an isolation valve and a check valve and an expansion joint. So this dumping system is present in all the preload tanks. So these valves can be operated from above tank. There will be reach rods which extend above tank. And we can see in this diagram, the line size is 12-inch schedule 80. So 12-inch pipes are used. Similarly, depending on different designs, the sizes change. Okay, so preload ballast system, we can see the system. It's a representation of the preload tanks and lines. Just okay, so now we can see preload pumps. So preload pumps, representation of preload pumps. So this is a design of preload pumps. These are submersible pumps, which is operated using some hose reel mechanism, etc., which we lower to sea during the preloading operation. Okay, so with that, we actually finished the presentation. We can move to the question and answer session. Whatever doubts, like any slides which you have doubts, even we can go to the slides again if required to clear the doubts. It's okay. So you can post the questions in question and answer, which is shown Q&A here. You can post the questions. First question, we have few questions. I will clearly show. Okay, how seawater will be available in the elevated condition in fire main system? Yeah, so elevated condition in fire main system. Okay, so this question was asked initially. Yeah, okay, I'll explain with the slide itself. In the seawater array availability during elevated condition, we will discuss about the raw water system, which is a seawater system. Okay, so this is a raw water system in elevated condition. So in elevated condition, this is submersible pumps provide water to the seawater header system. I mean the entire seawater headers will be fed by the raw water pumps, which are submersible pumps. So from this header, there is supply to fire system, which we can see in the fire system. So it is a build system. Okay, which we can see in the fire system. From the seawater header, we are taking suction to fire pumps. So these fire pumps in elevated condition gets water from the seawater system. Okay, next question we'll see. Emergency build suction will be available in rigs. Yes, emergency build suction is available in the rigs. So emergency build suction line will be provided in rigs similar to marine vessels. Couldn't see anything in slide 20. Just a minute. Let's see slide 20. Okay, this is slide 20. It shows the CO2 cylinders. Like this is a fixed firefighting. We use CO2 generally. So other methods are there, but CO2 is widely used. So first picture is emergency generator room. Second is the main generator room, CO2 cylinder arrangement. So emergency generator room being a small room with less volume, we can manage the volume with fewer cylinders. That's why we usually see 3 to 4 cylinders depending on the volume of the room. Also, for the main engine room, we can see around usually it comes around 80 to 100 cylinders for the CO2 cylinders for main generator room. For bigger, I mean more volume compartments, it can go up to 120 cylinders. Okay, we will go to, there is a slide 40. It's slide 40. Okay, we will go to slide 40. Okay, slide 40 is a preload ballast system diagram. You can see the slide 40. Okay, similarly, there is a question to show slide 39. The slide was blank during presentation. Okay, I hope slide 40 view is sufficient. We will go to slide 39. Okay, in slide 39, this is a preload dumping system, which is present in all the preload tanks. Because during operation, once the preload tanks are filled with water, I mean during loading, and the legs are lowered, after that we have to empty the preload tank. So for emptying the preload tank, we have similar kind of arrangement in each preload tank. There we can see that the hull bottom, there is a pipe with elbow. After that, there is an isolation valve, which the valve shown here is a butterfly valve with gearbox arrangement, which will have an extended spindle to the top of the tank, so that we can operate the valve from the main deck. Similarly, butterfly valve before the butterfly valve, there's a check valve. So, and there is an expansion joint with a pipe extension. Okay, so this is the arrangement. So check valve, this check valve prevents the inward flow of water. The check valve is only for the outward flow, so it is used only during the dumping operation. Okay, next we will see. Next question is, which software are generally used in piping system planning and design? Okay, piping system planning. I think you mean the planning for installation activities. We can use same this MS Project or Primavera software for planning. For designing, for 2D drawing designs, etc., we use the AutoCAD software. Similarly, nowadays, when we work with 3D scanning, we use software Scatmatic. Similarly, we can use CADWorks. Also, we can use PDMS. But PDMS is not widely used for offshore vessel design. It's used in oil and gas industry widely for plant design. But for offshore vessels, ships, or marine vessels, generally the widely used software is Catmatic for 3D design and CADWorks. So both these softwares are good for design. But for detailed design and the lower cost option, we can use AutoCAD software. Okay, there is a question. What are the pipe material requirement for seawater system? For seawater system, we use carbon steel pipes only because the seawater system headers will be mainly 12-inch, 10-inch size headers throughout the rigs. So entire pipes will be carbon steel. The coating requirements vary as per client because we can provide zinc coating for better durability. Also, for offshore, I mean, for long life operation, we usually don't see that much in the offshore oil rig. But for FPSOs, which need an operational life for 15 years, like 15 to 20 years, so such vessels use rubber lined, inside rubber lined carbon steel pipe with special coating like epoxy coating, etc. is being used, but it's very costly. So it's used for high long life requirement projects like FPSOs, which are completely stationed in certain areas for long period. And these vessels are not brought to shore. It will always stay in the deep waters. But offshore oil rigs usually does not have uh, much these long life requirement. These are frequently brought for inspections and frequently towed away from location. So offshore oil rigs use carbon steel pipes with zinc coating, which is a galvanizing process. Okay, we will go to the next question. Sanal, could you let me know the impact on the freshwater piping systems considering the floating and elevated position? What is the pressure differences, minimum and maximum? Do you recommend pressure control valves in freshwater pipelines to release the sudden surges of pressure to protect equipments like water maker, etc.? Yes, it is recommended. So generally in seawater system gets pressure fluctuation, like you mentioned. There is a pressure fluctuation because of the air gap variation for each side. The pumps, deep well pumps, which are lowered, pumps out water at certain pressure, but due to the air gap variation, there will be pressure fluctuation in the seawater header lines. So this fluctuation affects the equipments which use the seawater. So there is a pressure control valves. Pressure control valves are installed in the seawater header lines to keep the pressure controlled, like to keep the pressure constant in the seawater header. Similarly, freshwater maker requires a pressure control valve addition before feeding to the freshwater maker, so that the freshwater maker internal components, like even if it is an RO plant, the membranes, etc., to prevent damage to the system, it is recommended to use a pressure control valve. Okay, so I think that clears. We can see the next question. Is there class rules related to areas on which fire lines to be routed? Yes, there is class rules which clearly state the fire line routing requirement. So when we route to A60 compartments, I mean A60 fire-rated compartments, there are rules for penetrations. There are rules for materials which are used to be for fire lines. But mostly these rules, the mobile offshore drilling unit module rules, mostly match with the vessel rules, steel vessel rules, which are used for ship construction. But module rules details on the other application, like uh, like for helideck requirements. Similarly, for other systems related to drilling is covered in the mobile offshore drilling unit rules. But for fire lines, routing, etc., it clearly states guidelines in the class rules. Okay, there is another question. Does bilge collection requires pumps or through gravity? Bilge collection always require pumps because the bilge wells are at the lowest point. It is a well on the machinery floor space, which is the lowest point for bilge collection. So gravity collection is not possible in this system. We have to use pumps. We can use fixed bilge pumps like we discussed, the centrifugal pumps, or we can go for portable pumps like diaphragm type pumps, which can be operated by air supply. So that is a answer for that question. We will go to the next question. Is have any secondary arrangement for preload dumping system in case dump valve didn't work? Secondary arrangement for dump. No, for preloading dumping system, this is the arrangement. This is the only arrangement which is seen in the vessel. If such a case arises, like that is a possibility, like you mentioned, there is a possibility that it may not work. So the option is to give more dumping arrangement, like on the forward side and aft side, we can give preloading dumping for like 2 numbers per tank. That is an option. But this is the only dumping system arrangement which we see in the rigs. This is considering the cost factor. We can make a system better. Like we can provide more systems. We can incorporate more methods into rigs. But we know the entire oil field. I mean, the entire oil industry is day by day becoming more competitive. So to keep the cost under control, to keep the system in a just working mode. So there is a process. Like even if each tank has a dumping system. So even if one tank where is not working, the rig is designed with a safety factor. Like it can hold that dumping water there, and we can find a method to release it. So the other tanks can be emptied, and the rig can be jacked up. So it will not affect the safety of the rig. So all these safety factors are considered, and the design is always minimized to what is required to prevent the cost escalation. Okay, so next question. During jackup condition, is there a piping that goes deep down into the water from the rig for suction purposes? Or is the water fed from the hull tanks? If the suction pipe is laid down from the jacked-up position, how do you control the movement of this piping? Yeah, so this raw water header, which we mentioned, raw water deep well pumps are lowered to the water using a raw water tower. A raw water tower is a separate tower similar to it is a design. It is a separate design. So this raw water tower lowers the raw water pipe to the sea level. I mean the deeper pumps to the sea level. So this pumps supply suction to the raw water system. Okay, so during jacked up condition, this is the piping which goes down. This is a raw water tower goes down, and that supplies the raw water to the entire rig. Use the water from the hull tanks. Now, usually hull tanks, we don't feed from the hull tanks, but in certain rigs, such a design is seen. Like one or two tanks will be provided with a facility to store water and to use that water. But generally, it is for the transition mode only. But the system requirement, when we discuss about system, elevated condition, it is raw water pumps which feed the raw water to the entire rig. It is seawater to the entire rig. Okay, now we will go to the next question. Is load line convention applicable in piping systems, overboard discharge, tank vent, etc.? Yes, it is applicable. Also, next question, is a class certificate required for both the butterfly valve and the check valve shown on the slide? Yes, class certificate is required because it is a hull penetration. It should be class approved valves. So class certificate is required. The same hull penetration rules which is applicable to other parts of the vessels is applicable to the preload valves also. Next question, could you please explain why an expansion joint is required on the preload discharge line? Now, expansion joint is only given shown in this arrangement because there is a pipe spool which is connected to the system to prevent unnecessary load on the valves due to the heavy water stored in the tanks. To prevent any unnecessary load on the valves, we provide an expansion joint. So in case of any load which acts on the system, it should not come and affect on the valves. So that is the expansion joint is provided. Okay, we will go to the next question. Is the Diff system connected to foam system also, or is it a separate isolated system? No, Diff system is connected to the foam system. It is because Heredeck, we don't provide both options. We don't provide fire monitors and Diff system. We either provide fire monitor system, usually 2 or 3 fire monitors will be located. Usually 2 fire monitors will be located. In some rigs, three are given. And in alternate to this is the Diff system, which is a deck integrated firefighting system. So both these systems use foam. There will be separate foam tank. So this foam tank, which will be like a 3% aqueous film foam, or even higher graded 1% aqueous film foam is available. So if we use 1% foam, we can lower the size of the foam tank. So generally used is 3% because it is comparatively cost effective to use 3%, which is widely used. So this foam tank supply foam to the system for Heredeck firefighting. Even if it is for foam monitor or if it is Diff system, it has the foam supply. Okay, next question we can see is bilge stripping for preload tanks available? Yes, bilge stripping system is given for preload tanks because even if you dump the entire preload tanks, there will be a volume of water, which is actually a huge volume compared to the area of the tank. So this will stay inside the tank. To empty the water, we have bilge stripping lines given to the preload tanks. So this I'll show you a bilge drawing, which actually, yeah, this bilge section. In this diagram, we can see the lines taken from the tanks. Other than measuring spaces, we can see lines taken from each tank. So this is the bilge stripping lines, which goes to the bilge header. The bilge pumps are used to empty this. Empty the whatever preload is remaining in the preload tanks. Okay, so I think any more questions you can please post. Most of all the questions posted so far is answered. Anything which requires clarification or any slide, or if you need a recap on any system, you can post it in the Q&A. We can go through it for 2 more minutes. That's fine. Okay, I'm not seeing more questions. Okay, that's fine. Okay, thank you all for attending the webinar. We have discussed in this webinar actually. We will see the. Yeah, we discussed in this webinar today actually 4 systems: fire system, bilge, rover, and preload. Similarly, other systems are there which we will be going through in the next webinars, which we will announce. So we can cover like 3 systems or 4 systems in each webinar. So I'll be sending invite to all the attendees of the next webinar by email. Also, yeah, we have one more question. Noticed a blind flange at the suction point in the preload tank. Could you please explain its requirement? Noticed a blind flange at the suction point in the preload tank. Not in the preload tank suction point. I think the blind flange you must have seen in the dumping line. That is not the it is not the suction point. The preload tank dumping line has blind flange. It will be normally closed, like this blind flange for any maintenance operation inside the tank, etc. We close it with the blind flange. Similarly, this spectacle blinds are provided, which has one side opening and one side closed. So that is also used because if certain tanks which we are not using to prevent a malfunction, we can use the spectacle blind to blind the line and close it permanently. And during maintenance, etc., to have the safety on the person working inside the tank, usually it's closed. Even in elevated condition, as a safety guideline, safety protocol, it is mentioned in the operations manual. Okay, so I think that answers all the questions. Okay, all attendees, okay. Thank you for attending the webinar. Also, one more question: can we get today a recorded webinar? Yes, recorded video of this webinar will be shared with all the registrants and all the attendees. So you can watch the video. If any doubt, you can contact on the company email or inquiry, etc. Okay, so thank you all for attending. We will share the recorded webinar. We will wind up the session. Thank you.